It's another video in this series. So this video is part of a series, on the development of an app for the popular rock, paper, and scissors game. So the game that I just mentioned, which is the rock, paper, and scissors game, is a hand game for at least usually played by two or more players. So the players hold rock, paper, and scissors, and simultaneously each of the participants, right, forms their hand in the shapes of a rock, which is more like a closed fist, a piece of paper, which is like a palm facing downward, or a pair of scissors, like two fingers extended like a victory sign. So that's essentially, it's almost something along the lines of what you have on the screen. So the rules of the game are straightforward. First of all, rule number one, right? The rock beats scissors, and it does that by blunting like the scissors out. So rock, scissors, and rock wins. So paper beats rock, and it does it by wrapping around it and smothering it. And scissors beats paper by cutting it, and then in a case where both players produce the same weapon, in this case the same hand gesture, the game is considered a draw. So it's also instructive to say that most of the content in this video is actually based on material from the Developed in Swift exploration course that's provided by Apple Incorporated as part of their iOS app development course. And this book is currently available in the App Store at no charge. So the previous video that I made, which will be part 2, this particular video right now is part 3. The previous video, which was made part 2, was focused on the general description of the structure and organization of the entire app, the code, user interface, and all of that. So it creates a general description. And in that video, I hinted that we would use the model view controller design pattern, or I would probably say it's app architecture, more correctly stated, to develop the app. Now, model view controller design pattern, or what you call the MVC, is the default and also the native design pattern that's used in the iOS SDK which is Cocoa Touch. And I'm talking about the software development kit that's native to Apple for iOS applications. So the MVC is literally the native design pattern that's used. And for this reason, right, most iOS developers actually follow this design pattern for their application development projects. So what exactly is MVC? MVC. So it's, just think of it as a way of organizing your code, or organizing your app, in terms of structurally organizing your app for the development. And it helps you a whole lot of in so many ways to be able to keep organized and to know exactly what you're doing with your code. And the MVC is actually divided in 3 different boxes, right? Which is why it's called the model, the view, and the controller. So the model part, which is the first part you see here, right, is concerned about the application's dynamic data structure, everything that has to do with the data that the application would need, is in the model area. It manages the data, it manages the data logic, and all of the rules of the application. So if you want to get to know here some more, you might want to kind of watch the previous video And also, I'm looking to put out a video on app architecture and of course the app architecture and design patterns in some video in the future. You can always keep your eye on this channel to see it. So that's what the model does. The model is focused. So you're going to create these three boxes, and the first part is you're just going to focus on the model, work on the model, which is essentially all of the data that you need, and then the logic of that data. Now, the view has everything to do with the user interface, or more or less the front end of the app, right? So this refers to everything the user sees and interacts with. In terms of your app, everything you see usually on the screen of the phone, once you open up the app, everything you interact with. So the view also provides a visualization of all the data that the model contains. So essentially, once the data is prepared in the model, it eventually ends up in the view through the controller. So which therefore takes me to the controller, which is the third part, right? Controller just focuses on controlling the flow of data into the model object. So what tends to happen is you have your data in the model prepares that data, sends it to controller, and then controller does whatever it needs to do to prepare the data, further prepare the data, and then sends it to the view for display. So essentially, once there is an update to the data in the model, that update is communicated to the controller, and the controller communicates the changes to view, and the view changes what it's displaying. So in trying to develop your app, which is what the whole purpose of the MVP design pattern is, it gives you the opportunity to deal with each of these tasks in a different at different stages, literally like boxes, different boxes. So I am going to proceed right now to the main purpose of this specific video, because in this video, for the specific app we are looking to develop, the model would be our focus, which is what you have here, the first part of the MVC design pattern, and we are going to be focusing essentially on the model. And then so I already described to us what the game is all about. So to develop an app for a game of that nature that's being described, one of the things we want to do is collect all of the data. In other words, we're going to create a model of that game, right? So we develop the model data. By this we mean building the data types and the rules that would drive the game. So that's part of what we do as part of the model, which is the first part of the MVC design pattern. And then the second thing we want to do is we have to figure out a mechanism by which, remember, you're going to have two players, player one and player two. So you want to determine a mechanism by which player one can generate the signs. Now, when we say the signs in this particular instance, we're talking about the hand gestures that I talked about. So each of this is a sign: the rock, the closed fist, open palm, and then the V sign. Each of them is a sign, right? So we want to determine a mechanism by which player one can generate signs during his or her turn. So player one and player two take turns, right? Even though they happen almost simultaneously, to throw up signs, right? So we want to determine the mechanism by which player one can generate those signs during its turn. Now remember, what is going to happen is eventually we're going to create under view, we're going to create a user interface, and then we are going to put up graphical representations of each of these signs. And then how player one generates the signs is literally by clicking one of these signs on the screen. So it's more like a manual process, and that's going to be built in at some point when we begin to develop the view. So essentially, not much is going to be done with this second item here. The third item is to determine a way or the mechanism by which player two, in this case, is going to be your computer, because the way the program is being designed, you're supposed to be playing against your computer. We're determining a mechanism by which player two can generate the random signs during the app's turn. So in this case, we want the computer to randomly choose between one of those three signs randomly. Everything has to be very, very random and very unpredictable. So we're going to develop the code set to be able to do that. And the last thing we want to do is at the point where player one has already determined has thrown up signs, and the computer has also thrown up signs. Now we have two different signs, and those two different signs can now be used to determine whether the game has been won, that part of the game has been won, it has been lost, or it's a draw, right? And so what's going to happen eventually is that we're going to compare we're going to develop a code to compare the two sign instances to determine the game state, or the state of the game at that point, which we call the game state. And essentially there are four game states. And the first game state is the start, which is at the point where nothing is happening, which is where you have all of the three signs, right? And the three signs we are talking about are rock, paper, and scissors. So that's the first. At that point, nothing has happened. So it's waiting for the player to tap one of the signs. The second game state, right, will be a specific state where the player has won. So what happens is the app shows us the moves and then throws up a winning message. The third game state is when the player has lost. The app is showing each move that was made, and then plus a losing message. And finally, there is a draw, and a draw usually happens when the player one and player two throw up the same signs. So the app will show the move and then some kind of draw message. And this for the win, the start is pretty obvious. The draw is also obvious, but for the win and lose, these are all the combinations of possible win and lose. So when player one, which could be you or whatever player that's playing the game, throws up a rock, and the app or the computer throws up a scissors, it's a win. Rock and paper, it's a lose. Scissors and paper is a win, and so on and so forth. That's what we are going to use to be able to compare the two sign instances to determine the game state. So that's pretty much where we are with that. So one of the things you have to do is literally look at this diagram, because it's kind of illustrates what's going on here. So you have the game start, and then you have player one, more like player one takes turns, and then the computer takes turns, and then depending on what happens here, depending on what combinations, as you can see, if it's a lot, it could be a rock and paper, so it's probably a rock and paper, and then player loses, right? The next, it will be the player and the computer, and in this case, the player wins, which could be rock and scissors, right? And so on and so forth. And then the draw will be a situation where you have the player with rock and the computer throws up rock, and then it's a draw. So that's essentially what we have here. So what we're going to go do next is now try to put all of this into code form so that we begin to develop our app. Again, Remember, like I mentioned, our focus at this point is literally being able to deal with the aspect that's essentially model, which is creating all of the data types and then creating the data logic. Okay, so we will start by creating a new Xcode project. And then we want to go iOS app and then next. And then we want to name, the product name will be RPS, which is rock, paper, scissors. And then we have the storyboard, Swift, and then you click next. And then we want to save it on our desktop, and you can choose whatever location works best for you. So that has been created. So once you have this, one of the other things we want to do at this point is, the three signs. We want to be able to create, the three specific signs that we talked about, which will be the rock, paper, and scissors. So we want to be able to model that. So how you do that is, let me start by, first of all, creating a Swift file. So you click the Swift, the RPS folder, and then Control, and it opens up, and then New File, and then you choose Swift file, and then you open. Now, remember we're talking about the sign, so we're going to name this file sign, right? And then boom, we have created a Swift file. Now this file has been created, and you can see the file here. This is sign. See where my cursor is? This is sign. So we have our file here. Now, how do I represent the rock, paper, and scissors? Remember, at the very beginning of the course, we talked about different kinds of data types, and that's your way of literally representing actual objects in real life. So one of the ways, and the data type that is most fitting for this kind of representation is actually the enum. Usually this data type has a fixed set of related values. So you have a variable, and then it can be mapped to a fixed set of related values. And it's good for representing related data sets, right, that have a limited number. So for example, if I'm looking at a standard compass, the standard compass directions, I only have north, south, west, and east. If I want to create a variable that will represent that, enum or enumeration will be the best type of data set to represent that. Another example is the days of the week. There are just 7 days of the week. I can represent that with an enum, and I just name the variable day of the week, and then I just create only 7. And there's no mistake, because there can be 8 days in a week. It's just 7 days, and I log that in, and then I can play around with those objects. So that's exactly what we are doing here. So we are going to create, and this is a framework, Import Foundation. It's one of the frameworks in Cocoa Touch, something we probably would talk about some more when you see my video. I should talk about that in the app architecture and design pattern video that I will make very soon. So to create your enum, you go enum and sign, right? Open bracket and enter. Just a minute, enter. Sorry, open brackets, enter. Yeah, so I have that. So we start with case. The first case will be rock. Case 2 will be paper, which are the 3 different signs that we're expecting to draw. Scissors. So That's the enum for 3 of them. We've created 3 enums for 3 different cases. We've created an enum called sign, and it has 3 different cases. So the other thing we want to do is we want to be able to let me put this in here, to create some kind of physical representation. One way you could do this is actually get pictures, like image pictures, JPEG or something, and then just use them to represent. But in this case, we actually want to just use emojis. So we say var emoji, that's what we call it, and it's a string, right? And then we use switch self, and then we start with case dot space dot rock. Let's go. I'll have to tab case dot rock, case dot rock, and let me use a colon here, and then we also have a return value, so we're going to return something. We're going to return, let's return, so the return would be, what do I want to represent rock? Just a minute. All right. What do I want to represent? What do I want to represent rock? Let's say we will use, switch must be exhaustive. Can't call value of non-function, must be exhaustive. Okay, let's just finish with this. Return, we use control command and space, and then it's going to show us. So for the feasts, let's just type in feast, and then we can use this as our feast. Next, we will go with case. What went wrong here? What went wrong? Case, and then case will be dot paper. I'll figure out what I did wrong there. Dot paper, and then let's also return this. Return. And open and close brackets. Command, control, and space, and then for paper we'll use a raised feast. Yep. And then we go for the third, which is more like case dot scissors, right? And what are we returning? Return, open and close brackets, control command space, and then we're going to use the victory sign, right? And we choose the victory sign. Yes, and that's where we are with that. And what else are we supposed to be doing? Let me see. Sign, After switch, subject expression, case label can only appear inside a switch statements. Okay. Okay, gotcha. So I think we are good. What else is missing? Paper, okay. Colon and colon here. Okay. So let me go do this. Yep, I think we are good. We should be good now. So it's going to look something along this line. Expected. Okay, there's one more. Yep. So this highlights this. Okay, I think we are good. So now you've created a model of the three signs that could be thrown up, and you've essentially done that with your enum. So we're going to move forward to the next steps. What else do we have to do here? So next thing is I already discussed with us the various game states. Let me see if I can go back there. You know, we talked about the various game states, right? Which is your start, your win, your lose, and your draw. What's going to happen now is we are going to also create a a file for the game state. Remember, all we are doing here is developing different models for developing data models for each of the data models for each of the objects, and then the logic that drives them. So you have all these states, and we have like 4 states. So we're going to we do the same thing we did before: RPS, control, and then new file. So Swift file, and then you also open, and then this time you want to call it game states, right? And then you save. Right, so we have sign, and now we have game state. So same thing, you're going to create an enum, which is an enumeration, right? Because you have 4 game states: start, win, lose, and draw, and you want to create an enum called game state. So I'm going to go ahead and do that now. So we say enum game state, open, enter, and close. Open and close parentheses, and then we can start with case. The first is start, right? Case. The second is win, because we could win. Another case, which is a particular state of the game, could be lose. And then we have draw. So we've created all these expected enum case declaration, right? So we've gotten these done. So right now we have 2 Swift files, sign and game. In sign, we represented the various signs, and then in game, we represented the state of the game. And then we're going to proceed to now do a couple of other things. So let's go back to the file. Let's go look at where we are with this. So we've completed task number 1, which is developing the model data, as it were, or at least we started that process of developing the various data model data or data models, and the rules that actually drive the game. We're still in the process of doing that, but I need you to pay attention to number 3. Number 2, we already said was going to be manual, right? Because the first player has to enter something on the screen. So the second player, which is the computer, we have to be able to generate random signs, right, during the app's turn. right? How do we generate those random signs? That's one of the things we need to figure out. How does the computer itself go about throwing up its own signs once the human subject or player number one has thrown up its own signs? And that's part of what we are going to figure. And then once we have the signs from player one, which is the human subject, and then we have the signs from the computer, then we can go ahead to develop the code or an algorithm to compare both of them and to make a decision whether it's a win, lose, or a draw. So to excuse me, to do the part of determining how the computer will generate its random signs, right? We want to use some method, right? Integer method to do that, and you're going to see. So I'm gonna type a piece of code first of all in the sign. Let me just go ahead and type it here. Let's say random sign. We're creating a function. Where we here sign function random sign, open and close, and then we're going to point to sign again, sign, open and close, and then we can go ahead and type this. Let sign equals to, and I'm going to explain what's going on here very soon. Random in 0, 1, 2, 3, 2. Now, if the sign, is equivalent to 0, I think this should be capital sign too, sign, yeah, is equivalent to 0, go ahead and return dot rock, right? Else if sign equals to equivalent to 1, then go ahead and return dot paper, right? Else any other thing would be just go ahead and return dot scissors. Boom. So return sign. Okay, so I got all of this together. So one way to generate a sequence of values that are completely different from each other, once the app runs, right, is literally to use a method for strings, for integers called random. So first of all, integers is a sequence of whole numbers, right? Along the number line. And that's what we are trying to use here. And if you look at this, right, we're trying to map integer numbers to our signs, right? So one way to do this is to use a method. Integer has a method that's called random. And one of the parameters in random is actually what you call range, right? So if you want to create a range, let's say I'm trying to create a range from 1 to 10, right? My range from 1 to 10, I'm going to say something like 1. and then I'm going to type dots 1, 2, 3, which is what we call a close range operator. So I have a minimum or the upper limit, lower limit, which is my 1, and then my upper limit will be the 10, right? And between them is my close range operator. The dot 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 is the close range operator. And literally what I'm saying here is all the numbers between 1 and 10 inclusive, which will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's exactly what's going on here, right? 0 to 1 means it's not fractions, it's just 1. So after 0, the next thing you have is 1. After 1, the next thing you have is 2. So there are only 3 options, right? And we are saying let sign equals to some integer and then randomize this integer, right? And I want you to start from this lower bound to this upper bound. And from what we just demonstrated right now, there are only 3 integers between this point and this point. After that, it now says if this sign is equals to or equivalent to 0, right, return rock, right? And we already know what rock is, right? Rock, is the closed fist, so just return it. So if you randomize this again, right, and it throws up something again, let's say if it's not rock, else if it throws up 1, right, then just go ahead and assign it to paper, right? And if it is not 0, it's not 1, then the only thing it can be is 2. That's why you return scissors. So that's our way of, and it doesn't, the random method doesn't go sequentially 0, 1, 2. It can throw up 0 a couple of times in sequence. It can throw up 1, it can throw up 2. So there is the probability of coming up with rock, paper, or scissors. So I hope that kind of makes sense to you. So once we are done with this, I think the next thing we want to do now is actually to go do a comparison, right? You want to be able to, now the first player would have punched something on the user interface, which is on the view, and put in data, right, on the view, and then sensing that information to the controller, right? And then the controller brings it to the model here. Now we know that the first player would have, by punching the screen of, or rather user interface of the app, right, would have put in something. By this code, the computer has also decided what it's giving, the sign is throwing up. The next thing we want to do is to be able to actually compare those two signs, right, to determine the current state of the app, because the state could be, it's just starting, it's one of the parties has won, lost, or it's a draw. So what we want to do right now is create some kind of comparison, some kind of app or something for comparing lines of code for comparing those two situations. So, and we're going to enter that here, and that's where we do our comparison, right? So essentially what you're doing, you're comparing your player 1, the sign player 1 has thrown up, and the sign the opponent, which is the computer in this case, has thrown up. So I think I already wrote a piece of code for this, and I'm going to explain what's going on here. Random sign, we already have that, and we have get, yeah, this is it. Let me okay, command sorry about that, command A, command C, minimize, and let me command V. Yeah, I'm gonna remove this. Okay, tab. So, and this is literally the logic that says, you remember the logic, right? If the opponent's sign is equals to this, then it's a draw. If the opponent's sign is paper, so all this is doing is literally comparing the opponent's sign and which is player 1 and player 2, the signs they throw up. And essentially you're also using enums because there are only any number of signs that can be states that can I hope I did this right. Okay, so yeah, I think we are ready. So this function is you get your game state. It's going to go pull up this, which is the 4 different cases, right, for your game state, and then it will pick the opponent sign, right, and then we will game states, and then we'll go with the stats, self switch. So now it begins to compare what self is doing against what opponent is doing. So in case 1, which is rock, if the opponent equals to rock, right, or if the opponent is equals to paper, or if the opponent is equals to this, and then you have to return depending on, as you compare self with each of these cases, you return something. It's either a draw, a lose, a win. In this case, if it's a rock compared to self, when we're talking about self, we're talking about these options for player 1, and this is the options for player 2, and the opposite, and they are essentially comparing each other. So with this, you have actually developed the logic, which is your model part of the game. So our next focus, right, is actually going to go back to let me go back to the view where we're going to create the user interface, and eventually we are going to connect the model and the view using controller. So I think that's where we draw the line for this video. I know the video is a bit long, but I had to go on and on to make sure we kind of understood what was going on there. But if there are still questions, I will be happy to respond. All right, thank you guys. Appreciate you participating. I will catch up with you some other time. So thank you, and take care.